So today's problem is the last problem of the MIT 2024 Integration B regular season, problem number 20, which is the definite integral from x equals to 0 to x tending to infinity of, in bracket, 80 times x to the power 3 minus 60 times x to the power 4 plus 14 x to the power 5 minus x to the power 6, close bracket, times e to the power negative x. This is, I mean, from the very outlook, looks intimidating, but it's a very simple problem. Now, before I try to solve it, I'd like to thank our subscriber. Thank you so much for the support you've continued to show us. We don't take that for granted. We also thank our first-time visitors for passing by. What we do here at Everyday Mathematics is we go about on the run and look for interesting problems. We solve them and we share with you the solutions. For those of us who are back but haven't subscribed, we do really encourage you to consider subscribing to our channel. Subscribing to our channel for your support would really mean a lot in giving us that extra visibility that we need to move the needle forward. This problem is obviously, it looks ugly, but the thing that one could look at is there's so many x to the power 3, 4, 5, we could try and see a general approach to this. So if we have x to the power n times e to the power negative x, that can be expressed as the e to the power negative x can be expressed as the derivative of negative e to the power x. And using integration by parts, where if we have capital V d capital U being equal to capital U capital V minus the integral of capital U d capital V, where V now is our negative x, and then U here is negative e to the power x, and V is e x to the power n. Therefore, our U, the product of U, capital U and capital V, is negative e to the power negative x times x to the power n. And obviously applying the limits appropriately, minus, and then since we have this negative here, coming plus n x to the power n minus 1, which is the derivative of x to the power n times e to the power negative x. So applying the limits here as the limit of x tending to infinity of this, since this tends to 0, the entire thing tends to 0. And here, as x tends to 0, since this tends to 0, this entire thing tends to 0. So this reduces the integral down to n times the integral of x to the power n minus 1 times e to the power negative x from x equals to 0 to x tending to infinity. We can repeat that same process and realize we can keep doing it, and it continues in that fashion. The constant reduces all the way up to 1, at which x to the power 0 is what we get, and so this becomes 1, and so we have the integral of n factorial times, we have n factorial times the integral of e to the power negative x from x to 0 to infinity, or x and infinity. So when we integrate e to the power negative x from 0 to x tending to infinity, that becomes 1, and so our answer, because this tends to 0, right? And this tends to 1. X to the power, e to the power negative 0 is 1, minus minus plus. So we have n, the product of n times n and n minus 1, n minus 2, all the way up to 1. So n factorial. So what this tells us is that the integral from x equals to 0 to x tending to infinity, right? Of x to the power n times that is n factorial. And so what that means that when we have this problem here, and you multiply e to the power negative x across, this is 80 times 3 factorial, 60 times 4 factorial, 14 times 5 factorial, and this is 6 factorial. So 80 times 3 factorial minus 60 minus 4 factorial plus 14 times 5 factorial minus 6 factorial. 3 factorial is 6, 4 factorial is 24, 5 factorial is 120. And so 80 times 6 is 480. 60 times 24 is 1,440. 14 times 120 is 1,680. And then 6 factorial is 720. And so when you do this arithmetic, it all comes down to 0. And that is the solution to our problem. So it's a very easy problem, but it just did require one to have that general inkling. If you try to solve everything independently, yes, you might get to the answer, but obviously it comes at an extra overhead. So thank you so much for tuning in. This is the last problem of the MIT 2024 integration regular season. We hope you did enjoy following along. If you do want to see how the other problems were solved, please look at our channel. We do have all these solutions laid out. We do welcome your questions and your suggestions and your thoughts. We're here to learn. Thank you until next time. Bye-bye.